to do now. So here's one cool thing that came with the new release is that QA now, when you hover over it, you can see what types of tests you have to do. And so this is where we'll get into the QA agent. All right, now we're in the QA agent. We ran it by saying pl run qa.sh on the command line. All the agents print out their instruction set or their skill list, so it's an easy reference there. And it's gathering the information that it needs to test. So we have two features in the testing state. And here's the awesome part. So this is where PL Web Verify starts coming in. It's going to go in and run this headless Playwright instance to be able to test it. So the first time, okay, so this is the first time we're running it, right? In this instance, in this project with Claude. So we have to install Playwright, the MCP there. So we have to restart now. So I'll do that and then we'll come back, but it takes care of the install for you. You just have to exit and enter back. And now we're back and it discovered what it needed to do, and it's actually running and scripting the Playwright instance, which is pretty great. So a lot of tests that before would have been asking you to go and do some stuff in the app and then tell it what happened or send in a screenshot, all of that now is getting scripted and tested automatically. So huge time saver. Okay, and now we have a summary of the issues it found. Here are, most of it's passing. We had a fail, it did not have a spinner. Ooh, and the text color was off brand. So good findings. The way it records bugs now is in the feature file, which is fine, but you can see that there's it's probably not the best for the life cycle. We're considering adding a different file, another sidecar file called discoveries to contain these specific things and separate the concerns out of the feature file. But for now, they get managed by the agents and they're tagged as bugs, and they get resolved when corrected. So that's how it logs it. Tested the other feature with Playwright as well. Gave a summary. And yeah, the weather display failed QA. So we got to go back to the builder and say, do it right. So by telling the builder to do it right, I actually mean just load the builder again. It auto detects the to-dos because there was a fail, and it knows what it needs to do. So all I have to say is go. While the builder's going, it's a good time to mention some of the assistance that we put in Purlin to help manage state. Normally, you can just let it go and compress context. Generally, that works okay. It'll lose detail, but because implementation especially is pretty well compartmentalized, I found that if you let it overbound context and then compress it, it'll figure it out. However, if you're in the middle of something, or if it's between a couple of steps that really make sense to take a break on, you can watch for that, and you can just type pl resume save. Well, you have to stop it so it calms down, but you can queue up this command, and that'll save a state file, and it'll basically describe the work that it's doing and what it needs to do next, and give itself some context. And then you can clear context and then just type, when you return, pl resume, and it'll do a shortened version of a boot up of the builder and start going again. You can also, if you want to use one window and one terminal to run these agents, you can also switch back and forth by literally at any time hitting clear, like clearing context, and then saying pl resume, like, QA. And it'll turn into the QA agent inside the same instance. This, I think, is going to be useful when Claude finally gets its remote access working well, where it goes on your phone. The one thing that was a problem with that is you can't exit the instance and come back to it for remote control. You have to stay in the same instance. So this allows you to switch one instance between builder and QA and clear context and everything like that, and manage it all in that one window. And you can stay on your phone and talk to these bad boys. And here's another great thing that it's doing. So now to check that the builder, to check that it's actually doing the right thing, it's implementing its own tests. Well, it's taking the tests that QA would have run and it's running them in line with building the code. So it's checking it itself to see if it corrected the bug, which is really great. So now it hopefully won't spin its wheels trying to figure this out. It will evaluate it itself. And all visual spec items verified. Now, let me check the toggle interactivity. So there we go. Now it's passing it itself, but it doesn't get to say that it's passed, right? So it's like, I know this is going to pass. I'm going to ace the test. Go send it over to QA so you can validate it. Okay, to show you an example of PL resume, I'm going to clear the QA agent's context and then just do a PL resume. So without a save, the PL resume will just boot up really quickly and find all the stuff that it has to do and just go like you ran it from the start. So nice way to stay inside the same agent while switching roles or clearing context and just starting fresh. And looky here, it passed. So we had a successful run, and it asked if we want to mark it all done. Yeah, we can mark it all done. So that's kind of the loop. As the builder starts building and addressing errors, it tends to run more tests by itself. I don't know why it threw all the tests over to QA first right now. I've seen most of the time that the builder decides to just run the test as it goes and it figures out that it screwed it up. So generally you get better performance out of the builder when it can see what it's doing. I think one thing to mention while we're here is this critic, right? This is something that is a hidden sort of judge in the middle of all of these agents, trying to figure out if the rules of engagement are being followed. And it's a heavyweight process because it's actually checking for a lot of stuff. Like, did you write the tests right? Are there tests for every feature? Is the format of the files correct? So there's a lot of stuff going on. So it doesn't get run automatically. It gets run programmatically by the agents. There is a endpoint that is text only, which outputs stuff that is consumable by the agents to see what they have to do. And that same endpoint powers the web version here. And so sometimes they just don't run it, and you might think that there might be a discrepancy. So just hit this button. Generally, if it hasn't been run in a while, there'll be a minute or hour marker after here saying it hasn't been run. You can hit that and it'll run it again. So just a note about the critic. And by the way, we marked one thing done. We did not, so that was only weather display that passed. So now we have to go to Umbrella Advisor to make sure that it passes too. So we'll let QA do that, but I'll end the video here because it's going to pass. And yeah, we have our implementation. So the iteration here is pretty clear. Architect, builder, QA. If you see something in testing yourself manually at any time, so you're playing around with the implementation, switch to C, right? You're like, oh, great. Oh, it didn't work. Okay, well, maybe it didn't switch to Celsius. Okay, fine. The command for that in any agent actually is PL discovery. This actually, I think you can only do it in QA. We may move it to all the agents, but but if you just type PL discovery and just start typing, what did you discover? It will help you work out if you should mark that discovery as a bug or as a true discovery that doesn't match the spec. There's a spec ambiguity or incorrectness, and then that will be a to-do for the architect. And then you could work on it with the architect to figure out, okay, do we want to change the spec? How do we want to think about this this feature in a different way to give the builder the right thing to build and get it back in order? So that's how you keep the specs at the center of the world, right? You just keep iterating on, are we building what we thought we built? And is what we built working to what we think it should be? So yeah. One of the new features in Purlin 8.0 is the improved spec code audit. The previous one went into reasonable detail with the specifications, but it did not go very deep in the code. This one has a similar scan that stays superficial to compare the functions, the basic function to the specs, and then checks the specs for correctness. But it also has a deep option, which I ran here, which actually goes into all of the code. It spawns off subagents, so it strategically allocates parallel tasks to subagents and then spawns them off to go and do their own investigations into the code, then brings it back up to recommend changes. And so, so this was the plan. We had it send off the agents, and it came back with several high, one critical divergence from the code. The critical is actually a function that is defined, but it's actually changed during the specifications, and so there were some old definitions that need to be updated. There's also some things that are diverging from the anchor node. So this is a visual anchor node that says you must use named tags for colors and not hard code your own colors. And there are some hard coded colors in the code, for example. So this is calling that out. A number of incorrect anchors or undefined anchors. And you might not notice this in the code when you're running it because it'll fail gracefully or give a warning or something like that. But the big thing is that if you're specifying, for example, a policy, like a compliance policy, even small variations from that could be a problem. And so this is really helping get to the bottom of all drifts, true drifts in the code from the specifications, to help you figure out if you want to fix it and log the fact. It also logs all of these discrepancies so that you can provably say that you've come back and corrected the code. One of the new features in Purlin 8.0 is the improved spec code audit. The previous one went into reasonable detail with the specifications, but it did not go very deep in the code. This one has a similar scan that stays superficial to compare the functions, the basic function to the specs, and then checks the specs for correctness. But it also has a deep option, which I ran here, which actually goes into all of the code. It spawns off subagents, so it strategically allocates parallel tasks to subagents and then spawns them off to go and do their own investigations into the code, then brings it back up to recommend changes. And so, so this was the plan. We had it send off the agents, and it came back with several high, one critical divergence from the code. The critical is actually a function that is defined, but it's actually changed during the specifications, and so there were some old definitions that need to be updated. There's also some things that are diverging from the anchor node. So this is a visual anchor node that says you must use named tags for colors and not hard code your own colors. And there are some hard coded colors in the code, for example. So this is calling that out. A number of incorrect anchors or undefined anchors. And you might not notice this in the code when you're running it because it'll fail gracefully or give a warning or something like that. But the big thing is that if you're specifying, for example, a policy, like a compliance policy, even small variations from that could be a problem. And so this is really helping get to the bottom of all drifts, true drifts in the code from the specifications, to help you figure out if you want to fix it and log the fact. It also logs all of these discrepancies so that you can provably say that you've come back and corrected the code. One thing to be aware of with spec code audit is that right now it only does a feature to code comparison using keywords only. The match is reasonable, so it knows if the code is actually referencing the feature, but it doesn't actually go into the functionality of the code. That would be a very expensive process with tokens and time, and it just sort of isn't feasible right now. There can be an improvement, and we'll work on this in the future, where there can be at least one more level down of implementation introspection to see if code actually exists for the keyword match, so that you know that there's some implementation there. But right now it's just checking for the superficial match between mentions of relevant keywords in the code and the spec.